Data Skeptic is the official podcast of dataskeptic.com, bringing you stories, interviews, and mini episodes on topics in data science, machine learning, statistics, and artificial intelligence.
I was at the Microsoft Build conference in Seattle last month, and I had the opportunity to talk to a number of Microsoft team members about their data-related announcements. By the way, I also had a chance to meet up with a bunch of other great podcasters, shows like .NET Rocks, JavaScript Jabber, met up with Rob from Libsyn, who does Today in iOS and some other shows, and also was glad I got to meet Jeff from Software Engineering Daily in person. It's one of my other favorite podcasts, and I was recently on it, so definitely check out SE Daily. If you want to hear more about the software side of the announcements from the conference, those other shows cover a lot of it really well. Check out the links in the show notes. My focus, as you could expect, was looking into the data science-related details. This episode is going to be a hybrid of some of my own opinions and thoughts on the noteworthy news items, as well as interviews with David Carmona, GM of AI, and Rohan Kumar, General Manager of the Database Systems Group. So I want to take a few minutes first and share some of my thoughts on the conference, then get into our interviews. For example, at a high level, it was interesting to note some of the ways that Microsoft has been trying to reinvent itself for a while now. I'm definitely not a historian enough to really say when things started shifting, but it's no secret that what Microsoft was known for, operating systems first and foremost, Office, Outlook, Exchange Server, stuff like that, it's commoditizing. The company couldn't really be successful running its business the way it ran in the 90s, but that's a natural progression. You can say that about just about anybody. Today people are talking about automating machine learning and the data scientist is going to go extinct. And some of that is definitely hocus pocus, but some of it's definitely real. Now, like any big company, they've got their fingers in a lot of pies. One of the big areas is Azure, their cloud solution. So saying, Microsoft is doing their best to make moves in the cloud and compete with other big players is a pretty obvious move. I have my own sort of conspiracy theory, though, that I wanted to share here. Many of you know that Microsoft bought Minecraft for a huge amount of money. Now, Minecraft is awesome, and while I've never looked into the details, I'm sure it was probably a smart investment for them. But my conspiracy theory is that Microsoft didn't buy Minecraft just to sell plush dolls and toys and stuff, or at least get into the licensing of it. I think Microsoft bought Minecraft because they wanted people, especially young people, I guess, who are clever and trying to build things, to think Microsoft when they're building stuff. That theme, which I might be reading into, at least of being developer-centric, was really strong at the conference. Now, maybe I should stop here and say something. I know that that's a nice thing to say. This isn't an advertisement of any kind. If it was, I'd say so. Whether or not Microsoft is successful in that endeavor, you go ahead and judge for yourself based on the available data. I just thought it was interesting that is a strong part of the play. And I took away 3 major themes from this conference. First was just that, about this, developer focus and a commitment to that. I don't think that's new to them. I remember Ballmer used to talk about that, but I really noticed it in attending this conference. My second big observation is Cosmos DB. This conference was the big unveiling or general release, I guess, of that service. We're going to do a follow-up show all about that and about some other database topics in general, so I'll leave that topic for later. And third and finally, the theme for this show is really going to be about how things are changing in the service-oriented architecture space. There are a few things that I learned about at the conference that I thought were cool. And this topic in general of what we're going to do in cloud services versus on-prem is really interesting to me and central to many aspects of Data Skeptic. Some of you saw the talk I gave in Texas a while back, or maybe have caught the video online, where I posit, could it be that APIs are taking over all of the interesting data science problems? And if you saw that, I'm really interested in this concept of cognitive services. That's the idea that something like facial recognition, which is to a certain degree a solved problem, is now from the organizations that solved it, they offer it as a service. So you don't have to develop that on your own. If you want facial recognition as a first step in some machine learning pipeline, or maybe as the end goal for some software thing you're doing, you buy it per API request or something like that, and you get it built into your app, kind of in this commodity way that's kind of cool. And I think there's also a great opportunity for younger aspiring people or startups or places like that to get involved in these algorithmic marketplaces where you solve some really cool problem or some hard problem and you offer that solution as a service. So we're going to talk some about that with David when I get to him. My first day at Build, I had a chance to sit down with Rohan Kumar and talk about a lot of aspects of their cloud database offering. One of the things I found particularly interesting was work they're doing around threat detection. Now, I've been very close to a couple of bigger databases in my career, and in most of those instances, we hosted that database ourselves. Naturally, that meant our software engineers were trying to avoid things like a SQL injection attack. For those of you who don't know, a SQL injection attack is more or less a nefarious activity someone would do where they send some data to your website that tries to confuse your backend system and get some code to inadvertently run against your database. So if you were like filling out a form or something like that, maybe in your last name, instead of just putting your last name, you would put a quote and a semicolon, which tells SQL that it's reached the end of a statement, and then write some other statement. So I always had this great joke where the punchline was naming your child, single quote, semicolon, drop database. And no one ever seems to think that's as funny as I do. But the idea being that if your child ever were to type that name into a blank, that some number of websites on the internet would cease to work immediately because they were susceptible to the SQL injection attack. That sort of thing is preventable, but there's lots of other ways hackers and whomever might be trying to get access to your systems or harm them. In addition to a SQL injection, which is, basically a hack, you can also look at a lot of other metrics like, a time series of the requests that are coming from different IP addresses, and maybe a spike would indicate that someone's doing something that you don't like or they shouldn't be doing. So threat detection is an inherently unsupervised learning problem. You generally don't have a lot of good labeled examples of threats. Now, of course, you can go back through a corpus and label some of them, and that's useful, but they're also rare events. So typically you have tons and tons of examples of normal system operation. 99.9% of your data is that. And then you have this very rare imbalanced piece, this tiny fraction of known attacks, and that's just the ones you were able to find. Maybe one that was too subtle, didn't set off any of your alarms, might be there in the data, but since you didn't notice it, you didn't label it. But there's something interesting about that rare event being aggregated, and I'd never thought of this till Rohan mentioned it, but since Microsoft is hosting so many databases, as any cloud provider that does that has, they might be able to observe an attack over, a wide range of different training examples. This threat detection stuff's really interesting, so let's get into that interview segment.
We are able to, just given the access patterns across, at any point in time in Azure SQL database, we have close to 1 million plus databases that are active. The total number of databases that we host is about 2 million. So roughly like somewhere between, 50 odd percentage, right? So you're constantly collecting data around their access patterns. Right? So imagine, if you had a database and all of a sudden somebody tried to connect to the database, which seemed very different. In some sense, think of like how fraud detection works with credit card companies, right? There's a machine learning model against which they try to score whenever a transaction comes. That's exactly what we do. But the model that we are creating is based on the access pattern so far, right? If somebody is sort of sending some kind of SQL script which looks like SQL injection, there are very clear ways of detecting things like that. Then we are able to protect the customer's database. What we're doing with threat detection, we're using the same telemetry that's coming out. So every database, the queries that get executed against it, we anonymize, remove the PII data, and feed into this model. So let's say we made some changes on our side, or a developer made changes to their application which caused some of their workloads to regress. We are able to detect that with a lot of precision. And we either sort of, if it's our issue, we fix it automatically. And if it's something, let's say, where it's a customer's issue, then we tell them, hey, look, the schema change you made or this index you dropped or created is having an adverse impact on your performance here. Right? And a lot of that is being through the machine learning intelligence that we are building on query access patterns, right? So that's really, this is groundbreaking because of the cloud. You could never do this on-prem. You don't have enough data to sort of feed into the model and make it rich.
Every instance is a little different. What I might use my database for might not match what my neighbor uses his for.
Yeah.
How are you guys able to learn across instances where maybe we're doing different things with them?
Yes. So you mean like across different database instances?
Well, yeah, I guess fundamentally my question is about feature engineering. Are you learning from the system telemetry, or are you scanning the query logs?
The biggest thing is the query text that we get, right? So like there is, and which essentially tells us where there's a potential of an injection attack. Like predominantly, if you take a look at one of the biggest things you want to protect your database from is what's called SQL injection, right? Sure. Because everything takes a text query, so that's definitely one signal. And the other thing essentially is also the connection points. If you typically get, if you're behind the VNet, behind the firewall, and all of a sudden somebody's trying to connect from a place where we've never seen things before, there's a risk based on that, depending on how the length of your database, like how long your database has existed, that determines whether that's adding to a risk profile. Then we get a lot of telemetry data in the Azure Security Center around your entire app. So database is one part of it, but you have VMs. Are we getting signals from the other parts of your estate which says that, hey, your app could be under attack? It sort of is at multiple levels, if you will. Specifically from a database standpoint, the query text, the connection points, the system telemetry, like I said, on your VMs, etc., what we're collecting. It's while it's built into the service, I think today there's a small amount of charge you need to pay per user of the database. So it's not free in that sense, but yeah.
So in my mind, there's kind of two categories we can make about those types of threats. There is, someone is attacking my site directly because they want to do something negative to me. And then there's like something more like a phishing scam. It's like, let's just see if we can blanket every database we can find and compromise someone. Can you talk about the challenges around detecting these two types of attacks?
The broader phishing ones, if your signals are right, are slightly easier to detect because you're seeing the same pattern sort of. Where imagine if somebody's trying to log into several thousands of databases and they're using this, there's a pattern where you're seeing a lot of failures happen across. So we have DOS guards that are built into the system that they're able to detect patterns like these and block them. The individual ones are a lot more challenging. The machine learning thing comes in a lot more handy. Every database, their access patterns are different. The query text is different.
Yeah.
Right?
And there's probably no training data for the new attack.
Exactly. And this is where it goes to the duration of the database, like I said. Even after the featureization and stuff like that, if you don't have a lot of training data, there could be a lot of false positives. So how do you... And then, the challenge is if every time you contact the customer and say, hey, and then they're like, no, that's not an issue, then you desensitize them.
Sure, yeah.
It's like the crying wolf story. Like when you truly have an issue, they're like, look, man, the last 1,000 times you contacted me, it wasn't really an issue, right? And this is, again, something that we've been working for about 2.5 years now. The more we know about your database, which helps us train the model, the better it gets.
So the integration of R into SQL Server is relatively new, I think last year, and Python's much newer. Even though they've been out now for a while, I think any data scientist taking advantage of those tools still earns the title innovator at this point.
Yes, absolutely.
Do you have any maybe interesting stories of those innovators?
Oh, yeah. I mean, we have there's, I'd say, our ability to add R in SQL Server 16 has been, one of the highlights, of why the adoption of SQL 16 has been one of the fastest on-prem. I mean, there are other features, of course, we did operational analytics. There's tons of value that came in. But this thing really stands out as, wow, this is cool. I mean, this is something very different, right?
Yeah.
And so we have, I'll tell you, we have healthcare providers who are looking into optimizing, providing the best healthcare. We have a couple of hospitals, as an example, who are looking at a couple of things if you're running a hospital, like predicting the length of stay of a customer. So when a customer comes in, checks into the hospital, how long they're going to stay. The medical officer, what's called the ward lead managing the hospital, has to optimize for the number of beds, what kind of nurse, given the, so the efficiency just around that is very gated on predicting the length of stay. The other thing is the probability of readmission. When you discharge a patient, if they come back within a month, a lot of the insurance companies will refuse to pay the hospital. They say you didn't do your job properly, right? So being able to predict the probability of readmission based on a certain set of features, right? Like things you measure from the patient. So that's actually very critical. And believe it or not, these two, length of stay and probability of readmission, is what determines whether a hospital will make money or not. And they're using, all the patient data goes into the SQL database that they have, SQL Server. And it was more of an art than a science before we added the R capability into it. Right now, they're able to build more models based on the feature extraction, which is effectively patient data.
Yeah.
And collecting over like thousands and hundreds of thousands of patients that they get. And their efficiencies are amazing. Now, based on a couple of case studies that we worked with our partners, we have a very large group of hospitals in Japan who wants to try it out. Because for them, they're like, look, we already have this data. If we get this and it's going to make us run efficiently. So that's one example. We have lots of examples in the financial sector. We've publicly spoken about Jack Henry & Associates. It's a financial services company that one of their said customers are credit unions across the United States. And loan charge-off probability. So when you come and ask for a loan, they have to look at do a lot of experiments, like millions and millions of experiments per request on like what happens if, the economy of that region falls, age group, income levels. I mean, it's so complex, and typically that process takes several weeks. And this is why that process is slow. And with this ability to run R scripts, they're able to do close to I mean, I like several millions, like I think 15 million experiments for the model they run in 18 seconds. Right?
Wow.
I mean, so you see the disruption here, right? Something that would have taken weeks is completing within like hours or minutes, right? And so think about the change in the end-to-end duration of the customer experience for their customer.
So certainly some of that comes from the efficiencies we've talked about, that there's no network latency.
Correct.
But I imagine some of it must be sort of user efficiency as well, right?
Absolutely, right? Because now if you're taking important, like imagine medical data of a patient. If you had to take that outside where the compliance boundary, that's what causes the delay. And then of course the data volume is pretty high, so pulling that out takes time. The person who's authorizing you to do it has to make sure that wherever you're keeping the data is compliant as well.
Yeah.
Right? So this is what causes delays. When we basically say that, look, you don't have to do any of that. We are allowing you to run and do all this data science, create and operationalize, score against your models without ever taking the models or the data outside the database. Now you've suddenly removed all that barrier.
Yeah.
So this dramatic reductions that you see is not just scale and perf. It's just like this operation procedures that have reduced.
Yeah, all the compliance headaches.
Just gone, right? So,
Very nice.
So that's actually the big win.
Let's take a break from our show to talk about Periscope Data. Periscope Data has been sponsoring a lot of Data Skeptic episodes for a while now. We'd love to hear listener stories from those of you who've signed up. Reach out to me at kyle@dataskeptic.com if you're interested in possibly appearing on the show. For those of you that haven't checked out Periscope Data yet, let me give you the basics. Periscope Data is a dashboarding tool. The dashboards are incredibly easy to build if you know SQL. If your current workflow for doing analysis has any copying and pasting steps of any kind, you're definitely doing something inefficient. Check out Periscope Data and see how their solution might speed up the time to insight in your organization. You can learn more and get a free gift for signing up at periscopedata.com/skeptics. That's periscopedata.com/skeptics. If you enjoyed my conversation with Rohan, the full version is going to appear on the Data Skeptic bonus feed next week. We get into some interesting discussions about the migration of databases, which, let me tell you firsthand, if you don't already know, can be a very painful and difficult process. Although Rohan thinks they've just about got it solved with a tool they've built for doing database migration, even from prem to the cloud. Check out the full discussion to hear more about some of the questions I raised along those lines. As I mentioned earlier, I believe the landscape of available services that will emerge for data scientists to use over the next decade are pretty exciting. Training deep learning is very expensive and can actually require you to think seriously about the amount of energy that the machines are going to consume computing a model. But once a useful model is available, doesn't it make sense to share the wealth, to open up some sort of API for it? I think that's going to be a common theme as certain businesses solve very specific hard problems for their own needs, but see a more general audience as well. There's another really good punchline that I've never found an appropriate joke to finish with. But basically, it would wind up somewhere where we say something about all the artificial intelligence in the future is brilliantly good at recognizing exactly the types of objects that appear in the ImageNet corpus, but terrible at recognizing everything else. Just getting access to enough training data to do something interesting in image recognition can be really tricky. But building off the common tools, for some applications, a model that is able to recognize if a photo has a car in it or not can be really useful. But if you're working at a used car dealership, that's probably not as specific amount of information as what you need. But do you have to start from scratch and build a make-specific classifier? Or can you apply techniques like transfer learning to maybe leverage some of the other things that are out there? I had a chance to talk to David about how different people are using some of the services he evangelizes. I'm curious to hear more about the customization one can do in cognitive services.
Yeah.
For example, facial recognition in cognitive services is more or less a solved problem.
Yeah.
Now, maybe if I work at a company that does Halloween masks, that perhaps that would trick it.
Yeah.
And then I need to go to the customization route.
Yeah, that's a good example.
What are the steps for the person in that role to get going and to make that a reality?
Yeah, that's a good example. I'm going to use that example in the future, the Halloween masks. So I think a good way of looking at this is comparing to what we have now, right? So what we have now across the industry is you have a hard decision to make. If you are doing masks, then if you use a finished service and you run it through your data set, you are going to get all the time, this is a mask, this is a mask, this is a mask, right? There's nothing else, right? There's no custom training. Then you have to go to the deep learning wall. In the deep learning wall, then you have to train this over probably hundreds of thousands of images for really getting to the level of depth in that neural net that can allow you to get to that level of customization, right? I think with this customization in cognitive services, we added, because those two options are still there, and we don't think that those two options are invalid. They're both perfectly valid, but we added a new one in the middle, which is basically the way that it works internally is that in this case, so if you compare with any service in the past, there's one model that is shared across every single user that is hitting that endpoint, that REST API. What we did is that we instantiate a deep learning model just for you. So we have the concept of state in these cognitive services that you don't usually have in a service like this. Then once we instantiate that for you, we allow you to custom train that model. And you can do that very easily, both from the REST API, so you can submit your, in this case, if it's vision, then pictures, if it's voice, then sound. And we do that both from the API, but also with a very easy to use administration tool in a browser-based. So you can basically add a bunch of images, and you need dozens. You don't need hundreds or thousands, right? So for each scenario, just a dozen images could be enough in some cases. You just need to tag them or just use an existing data set, and that's it. From that moment, the model will be custom trained and you can use it from there. At any moment, you can retrain the model, and you can one by one, even for the images that you are using for your model, you can manually tag afterwards, so the model get reinforcement learning, right? So you can take it from there and really make it better and better over time. So it's a little bit the best of both worlds for developers that really want to have deep learning on their custom scenarios without getting into deep learning.
So for an organization like that, ready to embrace AI, about to take their first step, and I'm sure there's a whole spectrum of offerings they could be looking at, from cognitive computing to other options. What's been a typical gateway drug into the process?
I look at that from two different angles. One is the maturity. So we see solutions that from the maturity point of view, they are lower friction for enterprises to adopt. So it's a natural place for them to start. And that's the typical example that we see of that is how enterprises are embracing bots as a new user interface, and we see that all over the place, right? It's like almost getting to mainstream at this stage, right? Then you have solutions that are a little bit more complex and difficult to implement. It takes more time, so we see those lagging behind a little bit. That's one angle. But the other one that I usually use for enterprises to start from is just starting from the data that you have, right? So at the end, the AI is going to be as good as the data that you have, and AI is going to be as unique for your business as unique your data is, right? So what are the key data assets that you have in your company that nobody has in the industry? What is your intelligence? What is that data that really defines you as a business? If you have that identified, start there. That's a good place to start, right? And now think on multiple angles how you can use that data with AI to get to new levels, right? And I usually touch it's more like ideas to start from, right? So I always think of how you can use that data to get better products. So the product that you're selling, can it get better with AI? That's a good way to start. Or how that data with AI can help me optimize processes. That's usually I wouldn't say easy, but it's usually a first step that a lot of enterprises are doing is, hey, I have this process, I want to make it better, how can I optimize it, right? So that's usually low-hanging fruit. You can change the way that you communicate with customers. So what are your channels with customers, and how can you enhance those channels with AI? And then the last one is how you can make your employees more productive. So look at your employees, where are they spending the time, where are the assets from the creativity is empowering that employee and removing things that are not adding value to their final goal, and how you can use AI to really augment that employee's capability.
Are there any use cases that you're allowed to speak about that you find pretty insightful or novel or interesting?
An example that I love is an ISV AirDoc that we show it today. AirDoc has this amazing service for doctors to help them diagnose specific disease complication of diabetes, right? And that is actually a good example of how technology can really augment the doctor's capability, because it allows solving a problem in China of scale for doctors, right? So this makes much easier for doctors to diagnose and therefore scale and get to the whole population in China. That's a beautiful example, because from the technology point of view, starting on that side of the spectrum is you have a very deep, high-skilled data scientist, employees or technical people in that company, and they use the Microsoft platform to really be more productive, add more performance, and therefore being able to iterate very quickly in the algorithm and the deep neural net so they can get to the result that they were looking for. That's something that I feel very connected with. Then to bring another example on the other side, right, on the developer side, we show it today. Another example is a company called Human Interact. It's basically an indie game company. 100%, so this company is the opposite. It's 100% game developers, right? So they are 100% focusing on creating an amazing game, right? So no deep knowledge of data scientist skills, right? In their case, the problem is a good example because they had this issue, right? So they wanted to add voice recognition to the game. So I'm a developer. I don't want to get super deep on deep neural nets. So what do I have in the market? They try all the voice recognitions that they had in the market. And the problem is that because it was a science fiction video game, they used terms that they were very specific to the game, right? So they were made up terms, right? So you can't apply traditional finished services to power that solution. So what they did is using custom recognition service or the custom speech service that we provide as well. And that allows them to train on top of the initial service. They train that service with their own commands, right? And with that environment. So it worked for their solution.
Oh, that's very cool.
All right, everybody, like I said, another big announcement was that of Cosmos DB. It's a new and interesting player in the database space, so we're going to cover that in a future episode. Quick announcement, San Diego, Monday, June 12th, 2017. That's just 3 days from the release date of this episode. If you're in San Diego, I'm going to be giving a talk titled Leveraging Machine Learning with Bots. This is for the IEEE Consultants Network. You can find the details on Meetup. We're going to be at Giovanni's Italian Restaurant on Claremont Mesa Boulevard at 6 p.m. If you can't make that, I'm going to be giving a variant version of this, also in the chatbot space, at a talk in Minneapolis. That's in August. Stay tuned. I'm going to make the announcement as tickets become available for FarCon 2017. We were out of XL shirts. If anyone wanted a Data Skeptic t-shirt, those are back, so head over to dataskeptic.com and get one if that's your size. And lastly, I've been absent from the Slack channel for about 2 weeks. I've had some big projects to work on. Another week I'm going to be back in there, and I'm thinking we're even going to do some live chat type things. So if people are interested in that, let me know. Just, maybe DM me, say you'd be down for it. Maybe we'll pick a time and, do a follow-up discussion about the show or a Q&A or something like that. So sign up for Slack at dataskeptic.com as well, and you'll see me back on there every day in just a little bit. Well, until next time, as always, please keep thinking skeptically of and with data.
Data Skeptic is a listener-supported program. To support the show, visit dataskeptic.com and click on the membership tab.